So what I'm going to talk about today is what I call EarlyBird 2, which is a half-sized maze solver based on a Teensy 4.0, and I'll talk a little bit about what I started out to do. So the main thing was I wanted to build something that could run in Bernard's half-size maze. And the other thing I was constraining myself to was using the tools I'd already got. And I've laid them out there. I've got a temperature controlled soldering iron. I've got an SMD rework hot blower. That's about it actually. Hand tools. I haven't got a 3D printer. I haven't got a laser cutter, so I'm not going to be doing any of those clever things. So those are interesting design goals, but that's what I've got, and everything else has to go past project control at home. So we'll see how we get on. And the other thing I wanted to do was to keep in mind not just building it, but how do you commission it and test it and get debug stuff out of it, because actually that's how you get them running. And the first implication that came out of all of this, of course, is that size, getting inside the half-size cell, it sounds like a trivial thing to say, is quite tricky because it's small. It is small, and getting the stuff on there is tricky. So it immediately took me to, you need to make your own PCBs. You kind of almost forget about anything else. And I'll show you why at the end of this presentation. But you do have to make your own PCBs. It's almost the starting point for you. I could do some SMD because I've got the hot air, but I can't do a lot of SMD. I have to be a little bit careful about just what I'm capable of doing at any one time. I know we have big fans of SMD and we have other people not so big fan of SMD. The truth is size takes you there again. If you want to get anywhere near the half-size robot, you're going to have to do some of it. And then I wanted to basically go and look again at all the usual components that make up our robots and find suitable things in these categories. So I'm actually going to just tick off those categories now with you and explain what choices I made. And if you've got any questions at any point, just fire them away and I'll probably ignore them. Most encoders are the largest component, and by that I mean physically they are the largest bit of the robot, and in a half-size robot they are a bit of an issue. And gear motors, which we're all familiar with, and I think Bernard talked to them earlier on, they do a lot for us because they've actually got a shaft that you can put a wheel on, which sounds stupid, but that's a lot of engineering out of the way. The gearbox means you can have loads of choices of ratios, so that's all quite nice to have. They come with this nice extended shaft on the back. You can get odometry off them with low resolution, but nevertheless working odometry. So they do a load of work for us, and you can buy mounts. And again, you might think that's trivial, but if you haven't got a 3D printer, being able to buy a mount for a motor is quite a nice thing to be able to do. The point is that the standard ones that we use, if you wanted to put them back to back on a robot, they're just not going to work. They're just too big because they're too long. And I know that, I know for sure, Neil, you've used these ones before. In fact, you're still using them? Yep. And I think, Bernard, have you played with these right angle motors? He's not sure. Pimoroni right angle motor, which I think I should have a picture of somewhere, is essentially the same thing, but with a worm drive on the drive off the motor, and it takes its drive out at right angles. And the big thing about them is you put them back to back, and they're only 20 millimeters wide. So you can get one of those on a half-size robot, and it'd be viable. They're 39 millimeters long. And there's only one gear ratio. So it's not all pluses, but they are capable of being put in a configuration that you could conceivably get on a half-size robot. They're not going to go very fast. And as a spoiler alert, they're pretty horrible to drive as well. But I wasn't too worried about, if I can do 700 millimeters a second in a half-size maze, I'm a happy boy. Mounts aren't available if you want to mount them horizontally. So basically, you've got a choice with these. I'm surprised I haven't got a picture. I'm sorry about that. No, I haven't. So we'll go back for that. You can either lay them down horizontally, back to back, or you can stand them up. So have them vertically. I've tried both ways. I'm currently with a horizontal orientation, but you can do either. But when you lay them down horizontally, then all the motor mounts are wrong because they're designed to go over the gearbox part, and it isn't the right part of the gearbox because it's a different dimension and all the rest of it. So that caused me a little bit of a problem. I think we're all familiar with these encoders. My pictures aren't coming out for some reason. Is that your cheap LibreOffice, is it? Yeah, okay. Okay, well, I'll carry on because I think we're short of time. So I guess most of us are familiar. You can either get the original Palula magnetic encoders, which were a treat, but they've got horrible 6 connectors across the top of them that you had to somehow drag the wires out around the motor and horrible. But Primoroni do essentially the same encoder, but with a nice JST connector on it, and they really are much tidier. They give you the same resolution, and the only gotcha on the Primoroni ones is put the magnet on the right way up, which you don't have to worry about on the Palula one, but you do on the Primoroni, and you look at this dead encoder going, oh, this wheel's working and that wheel's, and you start chasing your wiring and all the usual debugging stuff, and then the dot's not in the right place on the magnet. But they're also quite compact, and they come in 2 orientations for Primoroni ones. So they either come out coming off the motor, or they come out, you can get another version that comes out at right angles. So if you're going to put your motors on in different ways, you can actually get good compact installation, and you've got a choice there. So I'd just say, if you're thinking about it, get those ones. They're much easier to work with.
Where does the other? What's the other orientation? You've got one on the back of the motor.
Yeah, they're both on the back of the motor.
Yeah.
So the motor's fixed in that if the motor was standing up,
Yeah.
you could either bring the connector out straight up or at 90 degrees.
Okay.
So it's really handy. Yeah. So I'm using the 90-degree ones because my motors are.
Yeah, I mean, I bought some motors that I did it one way, and then I found like they couldn't fit them close together because the cables made it too wide, so I had to take them off and use the different Primoroni ones. And,
Yeah.
Work quite well.
They work well, don't they? And you can buy the made-up cables, cut them in half, do what you want to do.
The other very small micro
motor bridge. I can cut through this slide quite quickly because we know the motor bridges that are around. I had used the SparkFun Toshiba-based one we use on UK Marsbot. I'd used it before on Asimous when I first built it. Very widely available. I find it quite intuitive to drive, but it's got a lot of pins. So it was a no-brainer for me when you find that the DRV8833 comes. It's got 4 less pins on it. I'll live with anything else that comes because I'm getting all that space back on my board. It turns out they're both fine. I don't enjoy driving the DRV8833 as much, but that may just be me and my familiarity. But they work fine, and they're smaller.
There's a variation on that I came across, that we found it, is what they make called DR Robot, and they use the same chip, it's actually a slightly smaller footprint. It's quite nice.
I wish I found that then. Because you take every millimetre you can get, don't you?
Absolutely.
So, microcontrollers. So much choice, right, in microcontrollers. But again, what was the point here? I wanted something that was compact, but had got lots of resources on it. And there are quite a few out there, but the one I actually chose, funnily enough for the title of the talk, was Teensy 4.0. And it's quite nice. It's footprint for a module is pretty small and viable for a half-size mouse. It has a lot of pins available, 34 pins available on that footprint through hole, almost. And then the rest of it, well, you asked me, well, it's got oodles of everything. Okay, it's just very fast, loads of flash, loads of RAM. Nicely supported device, actually. Very nicely. As software support for it is good too. So if you're using VS Code, you can literally just go and pull it, put it into VS Code, and it works. If you wanted to, you could use the Arduino IDE, Peter, because they've got a Teensy Duo or something for that. But I've not even tried it. I've not even looked, so I couldn't tell you. And all that stuff is there. Where I say 34 pins are available, some are easier than others because I can just. All right. So this is the bottom of the board on this side here. And it's a bit strange because actually these are 10 of the GPIO pins being exposed. Okay? So you've got all this stuff going on around the whole of the footprint, and then you've got these 10 in here. And it turns out that really what you're expected to do here, and that's what I've done, is you get right angle surface mount header. And you put that on there, and then your board can have all these pins come down on through hole. And it's a real pain. I found getting that header, right, because you can't cook this. It's your ready-made processor board. You just need to get the header on there. It's big and it's heavy, and you're trying to surface mount it with a hot air gun. And I found that quite tricky. I have obviously managed to do it, although I did lift one of the pads in my endeavours. You have to hand solder it, yeah. But because I didn't do it very nicely, I did definitely lift one of the pads. So I had a quick revision and look at my design to say, am I using that pin? Because I'm in trouble if I am. And it turned out I wasn't, so I was okay. But it's a very nice board. There is a 4.1, which is pretty much the same thing, but it has a built-in micro SD slot. I'll talk about that in a moment, but it makes it quite long. And surprisingly, maybe, its biggest drawback is not so much that it's long, but at one end you've got a USB connector, and at the other end you've got a micro SD slot. And it's very hard how you're going to get that on the board and physically access both of them, realistically. Well, it's not data logging. Sensors and data logging, right. So sensors, you've had loads about sensors today, and my sensors are the most basic sensors. They're the ones I know, and they're ones that work. And I haven't tried to reinvent that, so I'm using SFH 4550s. And BPW85Cs on the bottom. Quite nice because the 3mm part essentially sits inside the footprint of the 5mm part quite nicely. So nothing very clever going on there, but they work. Data logging, most of you know I'm pretty keen on data logging. A micro SD slot for me is pretty well what I want to do. It's quite nice. You just write your log as your robot's going around, sticks it on the SD card. You can take it out anytime you like. You can run again. You don't have to worry about getting your data out before you do anything. It's always going to be sequentially logged and so on. So I wanted to have that on the robot. But I'm stacking up quite a lot of things here that I want on my half-size robot. So these are the bespoke PCBs that I built. In fact, if you want to, I don't want to give you odd bits and pieces that aren't right. There we go. You can pass these around if you want to. If you would, I'd start a set over here and a set over here. So there's 3 boards. Of course, I've got boards to pass around because you can't get one set of boards made. You have to make lots. That's the bottom board. The top view of the bottom board. So you can see there, basically there, those are the emitters on top. Underneath, tucked in there, is the phototransistor. Motor mounts, I'll talk about those in a little bit because they're nasty, but the motors haven't moved yet, so I'm okay with that. And then a couple of transistors back here for driving these emitters. And you can see basically the mixture of surface and through hole what I've got. So I've got some surface mount resistors up here and some through hole, which these are the actual current limiting resistors for the emitters, and these are for the sensors, phototransistors, and then these are there's some more surface mount back there for controlling the transistors. The middle board, not too challenging. It's actually a battery shelf. That's what it is. So it just holds the battery. And then on top is the board with all the gubbins. So there's the micro SD card up there. Here's some of these are the cables going, the 2 ribbon cables that go down through to the bottom board. And here's that funny footprint. But all credit to them, you've got 10 pins in there. They're tricky to get out because they're already surrounded by all the rest of the pins of the board. So you end up doing some interesting routing to get out through the rest of the pins. But they're there, and actually I think I'm using 3 of them. So that means the difference between being able to do what I want to do and not being able to do what I want to do. Very simple regulation, 7805, push button, and I've only got room for 2 switches, so that's what I've got.
That's interesting you've gone through there, because I'm out of my motors vertically, but the problem with them vertically is I've then got to have huge great cutouts in the top board to take it, and then I've got not much space on the top board left. By the time I've got the microcontroller, which is a smaller one you're using, I've then got a narrow bit between the motors which to go to things on the front of the board. It gets very tight.
Tricky, doesn't it?
Yeah.
I'll give you a laugh in a minute because I'll show you something else. But so basically I went for stacking them, and as I say, the middle board is simply there to hold the battery off the top of the components on the bottom board. But it does actually tuck in quite nicely. Probably don't need to dwell on this too much. So there's the kind of pretty bog standard emitter circuits up there. I'm controlling the front emitter independently of the 2 diagonal or side ones because I wanted to actually not be firing them all at the same time. I'm trying to cut down the interference between the front, especially when you're going into a dead end cell. It gets very bright in there as you're getting towards the end of it. And then the detectors again, nothing very unusual there. And then there's the 2 ribbon connectors. So basically, you can't really see that very well. What am I bringing down here? I've got 5 volts, 3.3 volts, and then the 2 trigger signals from the microcontroller for the emitters, and then the 3 analogs back and ground. So 8 cables run from the bottom board up to the top board. And that's the top board. Again, that's the motor encoder coming up. They're coming up from the motors, and that's the beauty of those Pimoroni ones, because basically you come with your ribbon cable off the bottom and you just come straight to your top board. So I've only got 8 cables running from one board to the other. I've actually got the other 6 on each motor coming through as well. And that's what those 4 holes were for when you saw them in the middle board for the battery. They're to allow the connectors and the ribbon cables to come through. Nothing really else on there. There is Bluetooth on it. brought through, a standard 6-pin, just the 2 dip switches, 4 LEDs, and the usual power stuff. So, what might be interesting or helpful to anybody else? Commissioning, debug and tuning, which is kind of one of those things that we leave to the end and then I wish I had. I do one thing that is pretty untidy but actually is really quite helpful. You might see it, where can you see it on this photograph? You'll see it on the top of this, the motor bridge there. I use extended male header on the modules. So they can sit in a socket, or in this case they're soldered down, but they stick up above the module. So you've basically got a test or measure point on every single pin of every single device. It's really easy to do because you just use different header. And if you really don't like it, you bring your side snippers on and you clip them all off. But you get all those measurement points for nothing. And you can stick your scope on it, you can look at your motors, you can see whether you're PWM, anything you like. So it's a really silly little thing, but it actually gives you quite a lot of test points. And actually, I use it already. This horrible thing here is actually plugged into the test points that are extended above the teensy. And they desensitize the sensors for running in a half-size maze. So this will run in both sizes of maze. My intention was to run it today for this competition in the full-size maze, but actually I'm going to run it in the half-size maze. And that's the attenuator board there that desensitizes my sensors for the half-size configuration. And that, because all those pins on there, top of that teensy are presented, I can get those resistors put in parallel across my sensors just by 2 bits of female header. And just sit it on top. Take it off when you want to use it in a full-size maze. So I've already kind of used those test points, not in the way I expected, but I'm quite glad I've got them. I showed you the through-hole current limiting resistors on the emitters, and that's also quite useful because then if you find you've got the wrong kind of power going out and you want to get you want to put a lower current limiting resistor on there, get more power out through your emitters, which I in fact indeed wanted to do, at least you've got some points where you can parallel another resistor across. And surface mount that might be more tricky. So it was quite useful. The micro SD slot there, for me it's invaluable. And actually, once you've got a file system sitting on your robot, you start using it for all sorts of things. So you can, I dump out the settings every time, uniquely for every run. So I've got a log of data of something like, I'm not sure what I'm doing now. I think I might be doing 96 bytes of data every controller cycle, which is my debugging, logging data, yeah?
Can you write whenever that? Sorry, I have no experience with that.
No. You can write fast enough. I'm actually not. I've taken code from my other robot, so my loop cycle is 2 milliseconds. So I'm getting out 96, and I'll it's really another talk, but I am getting 96 bytes of data out, but I'm actually writing more than 96 bytes out because I'm actually writing it out as comma separated values even on this processor, which is so nice because you just put it on your laptop and it's there and you put it into a spreadsheet straight away. So I'm getting that out, so I'm getting those 96 bytes written in ASCII, comma separated on a 2 millisecond cycle, and that's not a problem. What it does depend on is which kind of one of those you plug in. Because if you buy a cheap, nasty one, you won't. Because they don't talk fast enough. But
accessing it, there's sort of 6 or 7 different ways of pumping data into one of those things.
Literally,
4 bits and 1 bit.
No, I am literally
It's
opening.
SPI.
I am literally opening it as a text stream
Yeah.
and writing it out as a text stream.
Well, what interface are you using?
It's
Point
That's
API.
I'm actually using the default pins for the Arduino SD library.
Right. Yeah, that uses the very fast ones use 4-bit access. And all sorts of weird
none
stuff.
of that. Nothing clever.
None of that.
None of that. I just went for, and you can test it out on the breadboard or whatever, and make sure it was all working, which is obviously. So it turns out that this little chip is really very good, and unlike my experience with Microchip's SD card library, which was painful, this seems to be really easy, and you don't have to be clever. You just write out the stuff you want.
I tried on the ESP32 before, and they just seem to get in the way all the time. It takes a lot of disabled interrupts for a long time, where it sets up the SPI to communicate with cards and
So has that chip got? A lot of those chips have dedicated, pins for that, or is it just on normal SPI?
It's just on. I mean, there are options.
You might find there's built-in hardware in
No.
chip.
There are options. This here, this other underside set of pads that are very hard to get to, is actually for the high-speed SD card.
Right, so you could connect one there. And
Yeah. So if you buy TNT 4.1, you don't get those because they're actually attached to an SD card. But I'm a simple soul, so I'm going to use whatever the simple Arduino default library is, and if I want to get clever afterwards, that's fine. And it turns out that this is really good. It really gave me no problems at all, he said. And then obviously Bluetooth. Why wouldn't you? Except you might have room for 6 pins. That's about the only reason you wouldn't. Lessons learned in future. My rookie error. Okay. And I got distracted, and I know exactly when I did it. I was drawing the board up for the top board, and I very cleverly connected RX to RX and TX to TX on the processor to the Bluetooth connector. So you'll see I've got a funny Bluetooth connector there because it has to go through a little board in between that does a quick swap on the RX and the TX. So that was just plain stupidity. Motor mounts are horrible on mine because they're modified motor mounts. They're not mounted the way I'd like to do. So whether I like it or not, I've probably got to look at 3D printing or getting stuff 3D printed to make sensible motor mounts for it. And I also wouldn't waste the time that I did trying a load of stuff out on something without the bespoke boards. And I said I'd give you a laugh because that has got everything the same on it as that. That doesn't really run. It does really run, but not for long. It's just too big, too heavy, everything's about it. The motors are horrible. I don't know what you found is they need an awful lot of static feed forward just to do something. They're just, yeah. And with wheels that size, boy, do you know about the slack, right?
I'm quite impressed because I think you've big wheels than I have, so on the new one, and I couldn't get my LEDs underneath with the small wheels I've got. All the intensifiers.
Right. Well, of course, you're looking at the back of the robot here. We've got another one with a picture. So those are those Primaroni encoders coming off the back of the motors there. Well, one of the reasons for choosing 3mm parts underneath was because of clearance, right? But yeah, I mean, this is still a bit high, if we're honest. This is incredibly high. incredibly top heavy. So it used to get going, and then it used to go, oh no, I need to stop a bit, and then you get this massive, great pendulum effect as the thing rocked. It was, well, it was amusing to watch, but it wasn't great. So you can't really waste time. You're going to have to go to bespoke boards. If you can do all surface mount, you'll get even smaller than I've done there. But that's the state of play at the moment. So yeah.
Something I've noticed on your boards, if you want to improve, and when you get to soldering even through-hole components, your annular rings of the vias are very thin.
Yes, they are.
So that makes it very hard for you to get heat on them and to make contact with them. If you make them a bit wider, like even 0.1 millimeter wider, you can make it much easier for you to solder either contact.
Thank you. Yeah. Well, I'm sure you're right. I think you're right. I actually took a whole bunch of defaults and got very lazy about my through-hole stuff and just said, oh yeah, those defaults will do fine. They passed the design rule check for JLC PCB, and everyone was happy. As it happens, I'm pretty happy with the through-hole, but you're right. I think. No, the reason I know you're right is because I had to change that capacitor there because it was just 0.5 millimeter too big and making contact with my encoder magnet and I had two choices, which was either to let the encoder magnet wear its own groove and carry on, or pop this out, and when they're not very big through holes, when you try and wick it out and solder second time through was a pain. It was really horrible. Any other questions? No, it was. We might. And if we don't, I have a video.
Yeah, that's why I put my video up first. If I'm wrong tomorrow, I can say, well, it worked yesterday. Thank you. Thank you very much.